two short little topics to do today. This first one, note the big white letters over there. What does it say? You cannot put this on your card. Why? Because I want you to know this for the test. All right, I want you to know how to do this without this written down on your card word for word. I've hinted at these things as we went through each of the four conic sections, but now we want to get real specific about it. I have over here a list of equations, and I want to figure out what each one will be. Will it be an ellipse, parabola, hyperbola, or circle? By just looking at the equation. And there's some things we need to pull together for how you tell. So, looking at that first equation, any gut instincts? You may look at your card as far as the stuff I've told you to put on your card. Why do you think parabola?
Well, it doesn't have the two things for a circle.
Okay, she said it doesn't have two quantity squares for it to be a circle. In fact, how many squared terms does a parabola have? If you look at your card, that's the typewritten stuff. Does it ever have both variables squared? No. Nope. That's how you always know a parabola. It'll have one squared variable. Okay, this is, by the way, this list goes on your journal. So if only one of the variables is squared, you're guaranteed it's a parabola. Okay, the next one's also fairly identifiable. If you've noticed, circles, ellipses, and hyperbolas all have x and y squared. They'll have both variables squared. Anything special you noticed about this one? The minus.
It would be hyperbola.
Yeah, which was the only one that where they were subtracted. Hyperbolas only. So they will have two of the variables will be squared, but they'll have opposite signs. One will be positive, one will be negative. It's the next two that I think are the hardest. Because if you look at these next two, there's only one thing different in the whole problem. The third one's got a 4 on the bottom, this one's got a 9. Otherwise they're identical.
Oh, the bottom has 9 and 9.
Circle, the denominator on circle will always be the same number.
Yeah, circles, if you call it, have that same coefficient in front, whether it's divided or whether it's up on top. If it has the same number, it's going to be a circle. That's what makes a radius, because you're going the same in both directions. Whereas this one has a 9, then a 4.
A and B.
That's A and B. That's going to be your ellipse. Notice, though, they're both squared variables. They're both positive here. You don't have one positive and one negative. They're both positives. So, on an ellipse, you'll have two squared variables. They'll have the same signs, meaning both positive. You could have them both negative, but it would be weird. But they will have different coefficients. Whereas circles will have the two squared variables, same signs, same coefficients. It's pretty easy to tell when they're in standard form, and those first four I had in standard form. But what if they're worked here where they've been actually worked out, foiled together, all that good stuff. They're not in standard form, then what are you going to do to tell them apart? Well, the same rules apply. The only terms you worry about are the squared ones. The other terms are there just to help you to complete the square and all that stuff. The only ones that affect it are the squared ones. So, looking at this next one, find the squared variables. We got a 3x squared and a positive 2y squared. Both positive. Both squared. Do they have the same coefficient? One's a 3, one's a 2. Okay. They're different coefficients, so therefore it's an ellipse. All right. Next one. Find the squared variables. We got the 2x squared up front. We got a minus x squared in the back. Is it two different squared variables?
No, it's hyperbola.
They're both of the variable squared is x both times.
So it's parabola.
So there's only one variable squared. Is y squared?
No.
There's no y squared. So it's only one squared variable. It's a parabola. That was mean and evil, but it's okay. I have several of these that are intentionally mean and evil. Yeah. Okay, so, all right, next one. Got a 9x squared. Over here I see a 3y squared.
That one would be less than square has got two different square variables. The rest positive. No, hyperbola because they got the same sign. Yeah, well, it's hyperbola. The other side. The same side.
There is the question. Do they have to be on the same side before you can decide? Yeah, they do. So I need both squared variables on the same side of the equal sign because I can't tell the right positives and negatives. So I'd actually have here 9x squared. If I brought that over, it'd be minus 3y squared.
So that would be hyperbola.
So since they're subtracted, yeah, it's a hyperbola. Okay. So here I have a 7y squared. Back here I have a negative 7x squared. But I'd have to put them on the same side. Yeah, I'd have 7x squared plus 7y squared if I brought that one over here to the left side. So they're both positive and both the same number. Yep, that's circle. Ooh, so what's the last one? It's an odd one. We've already used them all twice.
Okay, so it has two different squares. Hyperbola. They're different.
Okay, so they're both squared.
They're negative.
One's a negative, one's a positive. But they're the same number, same coefficient. Yeah, it doesn't matter. If they have different signs, if they're subtracted, it's a hyperbola. Because hyperbolas, it doesn't matter whether they're the same or not.
So will we have one focus for practice on our worksheet?
Yes, you do today. Yeah. You have a whole, like, you have 12 of them to look at, but all you have to do is look at it and go, which one is it? You're not working anything out. It's just look at it and identify it. And if I remember correctly, yeah, you have to do them all. It will not hurt you to have to look at all 12 and practice that. Eligible people, this stuff shows up. Here's the equation. Which conic section is it? I guarantee you I ask it at least once every year when I write the questions. Okay, so that's called classifying. Now,